Good evening, ladies and gentlemen. Tonight's lesson is on factor trees 2-3. And our goal is today I will write a number as a product of its prime factors. Okay, I love most math, but I really love factor trees. They're fun, they're quick, there's kind of something nice about, you'll see, creating this tree structure. So our vocab tonight is kind of the big one. Our first vocab word is factor. A factor is a number that is multiplied together to get an answer. So we could have a factor of 2 times 4 equals 8. And the factors are 2 and 4. So when they're multiplied together, they get 8. You could have a factors of 20 times 20. And if you think about one of our skills in the last unit, 20 times 20 is 400. So my factors are 20 and 20. So factors are numbers that can be multiplied together. Okay, a product is the answer. So the product is a multiplication answer. And we had that in our last set of notes as well. So multiplication answer. So think of multiplication. Okay? So factors are numbers that can be multiplied together. Another thing about factors is sometimes I use the word for factors. They're numbers that fit in. So sometimes if we're thinking, well, 12. What factors are 12? What numbers can I multiply together to get this product of 12? This is my answer. So what numbers can I multiply together to get this product, this answer? And it's going to be numbers that fit into that perfectly. So I could multiply together the factors of 1 and 12. My factors could be 2 and 6 to get the product of 12. I could have 3 and 4 to get the product of 12. And I'm going to stop right there, but all those are factors that will get me this product. So these numbers all fit into this perfectly. 1 fits in perfectly, 2, 3, 12, 6, and 4. 5 does not fit in perfectly. 5 will fit in at 2 times, but then I would have some left over. Okay? So factor and product work together. Okay, our next 2 vocab words also work together. Composite number and a prime number. Okay, most numbers are composite numbers. What a composite number is it means it has more than 2 factors. Has to have more than 2 factors to be composite. So if you think about 12 that I just did up here, 12 has 1, 2, 3, 4, 5, 6 factors. 6 numbers that when I multiply them together, I can get 12. So a composite number would be 12. 12 will be a great example of it. Okay, let's try another one. What about if I did 9? What numbers how can I make the product of 9? Well, I always like to start with 1. So 1 times 9 will get me 9. Then I always like to go just in order. So after 1, I'm going to try 2. 2 times what will give me 9? Nothing. That didn't work. What about 3? 3 times what will give me 9? 3 will. And I'm going to stop because once I have what's called like a repeat here in the second column, then I know I've hit all of them. So 9 has 3 factors. It has 1, 3, and 9. It has a total of 3 factors. Okay, let's try 20. Okay, so for 20 I have, let's start with 1. 1 times 20. Okay, let's try 2. 2 times 10. Let's try 3. 3 times, 3 didn't work. Let's cross it off. 4 times 5. And if I go to 5 now, I'll have a repeat. So I'm going to actually stop. So if I look at 20, 20 has 1, 2, 3, 4, 5, 6 factors. So again, it's called a composite number. Okay? We could try this with many different numbers. We're going to try one more. What if I tried the number 36? Okay, well 36, we're going to try 1 first. 1 times 36. 2 times, well this is a hard one because I know 2 is going to work because we've been talking about our divisibility rules, and this is divisible by 2 because this 1's place is. So I might have to count by 2's if I need to, okay? But I know it's 2 times 18. Then I'm going to try 3 next. 3 times 12. I'm going to try 4 next. 4 times 9. I'm going to try 5 next. Ooh, I know 5 doesn't work because we've been talking about that divisibility, and for 5 to work, this would have to be a 0 or a 5. And then I'm going to try 6 and 6 times 6. And since I had a repeat, I'm going to stop. So how many factors did this one have? 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't count the doubles. So this had 9 factors. So that's a composite number. Okay, our next number, which kind of goes with composite numbers, are prime numbers. Prime numbers have exactly 2 factors. Has to have exactly 2 factors, okay? And they will always be 1 and itself. Okay, so think of a number like 5. I have 1 times 5, okay? 2 doesn't work. 3 doesn't work. 4 doesn't work, and 5 would be repeating, so I'm going to stop. So that means the only factors of 5 are 1 and 5, which are 1 and itself, and it has exactly 2. Okay, so let's try another number like 3. 1 times 3, 2 times doesn't work, and 3 would repeat. So that tells me I can stop. So again, it only has 1 and itself. The most common prime numbers are, this one's gonna, oh actually let's try one of this one because this one always surprises people. 2. 1 times 2. And then if I go to 2, it repeats. So 2 is actually a prime number. It's the only even prime number. So our most common prime numbers are 2, 3, 5, 7, 11, and 13. And we could go on, but those are the ones that we probably want to become most familiar with. Okay, this kind of throws some people off. 0 and 1. 0 and 1 actually are not prime or composite. They really don't fit into either category. Now 0 really has an infinite number of factors because you could say 0 times 1 equals 0, 0 times 8 equals 0, 0 times 2 billion equals 0. So because it has an infinite number of factors, we don't really call it composite. Now prime, 1, the reason 1 is not a prime number is because to be prime you have to have exactly 2 factors. Well, 1 only has 1 factor, which is 1. So numbers 0 and 1 are not prime or composite. Okay, that's a lot of new vocabulary, but we'll be practicing it again and again. Okay, so our notes are kind of rules. We're going to be making these things called factor trees, and here's the rules that I've created to help us. First, no ones allowed. No ones allowed. They're not going to be allowed in your factor tree. And then all branches are going to end with something I'm going to call apples, which are really going to be your prime numbers. So these are going to be the two rules that you're going to be following when you make your factor trees. No one's allowed and all branches must end in apples. Okay, so what are our steps then tonight? Our steps are, first, you're going to create a factor tree following the rules. Then you're going to write your factors, which are your apples, which are also your prime numbers. So our factors are our prime numbers, our apples, in least to greatest order as an expression. And then I put some hints here. One, you're going to want to cross off as you go. You might end up with a lot of factors, and you might lose count if you're not crossing them off. Another hint is trees may look different, but there's only one correct answer. And I'll show you what this looks like, because we can attack the trees differently, but we always should end up with the same answer. Okay, so we're gonna make some trees. And remember, our rules are they must not have ones in them, and we have to end all of our branches in apples. So I'm gonna kind of leave my steps up to help me as I make my first one. Okay, so my first one's 20. So here's how I'm gonna make these. I'm gonna ask myself, how could I break 20 apart? 20 is kind of like my product. What factors can I use to break 20 apart? Well, I know that 2 times 10 will give me 20. So I'm going to write 2 times 10. Okay, now I'm going to come over here and say, how could I break 2 apart? How could I break 2 into factors? Well, I could say 1 times 2, but I'm not allowed to use ones. So what else could I use? Nothing. Hopefully you've come up with nothing. There's nothing else, which means I need to end that branch in an apple. So let's try this one. How could I break 10 apart in factors? And I can't say 1 times 10 because that's not allowed. So I need to use 2 times 5. Okay, well we've already figured out 2's are going to be apples, so I'll circle that. What about my 5? Can I break 5 up into factors? Or does it need to become an apple? Let's see. What times what will give me 5 without using a 1? Nothing, which means it's a prime number. Okay, so this is called my factor tree. No ones were allowed. Now this is a 1 and the 10, but that's not a 1, it's a 10. I ended all my branches in apples. So now I'm ready for step 2. Write my factors or prime numbers or apples in least to greatest, crossing off as you go was my hint. Remember that little cross off as you go? As an expression. So I'm going to have 2 times 2 times 5. And that is my answer. Okay, so I had told you that we could try them differently. I could have also done 20 as, instead of 2 times 10, maybe some of you were thinking 5 times 4. Well, watch how my tree is going to be different, but my answer will be the same. 4. How can I get 4 without using a 1? 2 times 2. And then what did we realize? Our 2's are going to be apples because they're prime numbers. So, again, I'm going to write them least to greatest, crossing off as I go. So 2 times 2 times 5. So even when your trees look different, your answer should always be the same. Okay, let's try another one. 18. So hopefully you're thinking ahead of me. What can I break 18 up into, what factors without using 1? Well, I could say not 1 times 18. I could say 2 times 9. I could say 3 times 6. I think I'll go with 3 times 6. Okay, well 3 is a prime number. I can't break that up, so I'm going to make it an apple. 6 is, I could say 2 times 3, and I know those are going to be apples because those 2's and 3's are prime numbers. So how would I write this? Well, least to greatest, I'm going to say 2 times 3 times 3, and that is my answer. Okay, my last one I'm going to do is 7. Okay, 7. So I need to break 7 up into its factors. Now remember the rules, no 1s. Are you stuck? You should be, because I can't. The only way I could break 7 up is 1 times 7, which means that's a prime number. So I can't make a factor tree for it. Okay, so let's try some of these. All right, number 1 is 12. 12 is one that you could break up many different ways. I think for this one, I'm going to say 3 times 4. Okay, well, hopefully we've kind of realized our 3's are going to be apples because they're prime numbers. And then 4, what do I have? I have a 2 and a 2. So my answer for this one would be 2 times 2 times 3. That is my answer. Okay, 24. We could not do 1 times 24, but we could do 2 times 12. We could do 3 times 8. We could do 4 times 6. I think I'll go with 4 times 6. So 4 I could say is 2 times 2. And 6 I could say is 2 times 3. So you're going to start seeing that you'll be really comfortable with what become apples. So we have 2 times 2 times 2. How nice. This one was already in order, least to greatest. Times 3. Okay, tonight you only have 2 to try on your own and then rate yourself, and we'll practice this more tomorrow. I hope you like this as much as I do. Have a great night, guys. Bye.